For the lab of today, you have the next part of object-oriented programming, as well as how you should write your code such that it will have a good quality. So first of all, you've got the static members. You've seen that you are having the static functions, and you also have your instance. Members, variables, okay, and methods. Meaning that if you have an instance member, well, first of all, you have those instance methods that belong to this object, such that you can access them via the reference. As you are having a class person, let's say you have an object of that class of P as being equal to new person, so you should call the default constructor, or you can add several parameters. Then for it, you have an instance variable, such that you will have a field. You have the field that exists inside the class, you allocate it, and whenever you have a new object of a class which is created, it will have these fields that are associated to it. So they will be non-static. Then you've also got the instance methods. So this one is that for your instance of the class, the object, you have several methods which can be called. Again, whenever you have several objects of the same class, like you've got the same different persons, and you use also the same class, you can have the constructor, the default constructor, or the one for which you provide some parameters. You will also have some methods inside the class which will be shared by all the objects of that class to which it belongs. Whether you have your static members, it means that you will have your static variables as well as methods inside the class, and you can only have access to them via the class name, okay, or whether you have a reference to it. Okay, so whenever you've got static, you can use just the class name and you can call it. It is not like with the instance when you need an object of that class. Then when you've got a static variable, this means that you will have your field, which is simply allocated whenever you have your class loaded. So remember that it's the class, it's not the object, okay? So it belongs just to the class. And in this case, it is called a static field, or you can name it as being a class variable. Okay, so it is generally available no matter the type of the object. Also, you have your static method. Again, this one belongs to the class and not to a certain object of that class. So it is generally available for it. So let's see over here. In this way, you have an employee. An employee is characterized by a name, you've got a salary, an ID, as well as you see that as in databases, you will have a record. And this record is generally available for every member of the class employee, such that it will be a private static int next int. So it will be the next record of type employee that you can store. And in this way, we've got employee who is characterized by a name. So you initialize the name with n, you will have the salary as being the one which is provided, okay, this being the constructor. You've got the constructor of employee, and the ID will be the next value which is available. So as you can see, when you want to assign an ID value, this is a post incrementation. So this one will return, in fact, 1 when it's called the first time, and then it will be simply automatically updated. Also, you've got the getters and setters. You can get the name such that you return name being of type string. So this is why you have the public string get name. When you want to return the salary, you need to look at which is the type of salary, and it will be a public double, and then you have the method which is get salary. Okay, for which you do the return. Also, you will have the get ID. So basically, based on get ID, you will have to return a value which is of type int, and you return it one by one. when you want to set it, it means that the ID is the current value, and then you simply increment it. So this would be a post-incrementation. And for example, for your unit test inside the void main, you're going to have an employee named Harry, and you provide the salary for him, such that you can call get name and get salary. So, let's see. It looks like right. So okay, you will have this employee. Oh, bye. Okay, you have the employee. So as you've seen it, you can have the name for it. So with the salary, you also initialize, which is the ID for him, starting from value 0. Okay. And so you can start from 0 or from 1, as it is here. Okay, for which you can also have a final field, but when you have a field, you see that you cannot update the value, such that whether I want to set the name, it will say that you cannot assign a value, so a new value to your existing variable name. Okay, but you can do it based on the constructor. Also, you will have this get ID, so you return ID, which is of type int, as well as you have set ID. And your ID will be equal to next ID, for which, okay, this ID gets equal to your static field, which is automatically incremented. Then when I want to display the details about Harry, I will have him, okay, with ID, name, and salary, such that firstly, we have on record 1, okay, the ID, we have Harry, and then we have a value, which is the salary, okay, being double. So this is why you have this dot 0 at the end. Also, you have the second record, where for the second record, you see that you just provide inside the constructor just the name and the amount of how much the person earns. And when you will call the get ID, you see that the value, okay, is this 2. Okay, so it will be the automatically assigned one, and you simply have it display. All right. Clear for everybody why you have this static fields? So they are just provided for the next records that come, such that you can use them and they will simply be automatically updated. Okay. Like you have persons who register, you have them one after another, and in this case you have a counter. So this global counter knows how many persons did use your service or how many employees you've got. Okay. So it is like you have your account number assigned to you at the end. It is like you are a student registered to University Polytechnica of Bucharest, and that number, when you were stored per faculty, it was assigned for you based on your subgroups and groups. Then you have the lifetime of variables. So for your static variables, they exist when you have your class loading, okay? And as you have the class available at runtime. So here, when you have it loaded, okay, it will exist. And when your program finishes, it won't exist anymore. Then also, when you've got the instance variable, this is for your object, okay? And this one will also exist as long as it is at runtime. It is this E, okay, which you've got over here. So E and E2, they all exist at runtime. Then you have your local variables. So the local variables are the one which exist inside. Okay, but when you have something like this dot name or like this name, it refers to your attributes of that class. And also you can have an I So you can have a counter for your loop. And this is the case when you've got a local variable. And they exist inside methods. When you have constructors, blocks of code are based on your methods, are based on your loops, based on your if-else blocks. Okay, and you have them, all of them, they are created when you just execute them. So when you are not at execution time, like here, you cannot reference anything. Okay. Then when you want to initialize, you've seen that you can initialize based on fields, you can set a value, or you can also have them in this way. You can have a square matrix based on your dimensions. So you can have your static initializer. So this means that it is executed when you have your class loaded. So don't forget, static is per class, your instance variable is per object of that class. And now for it, you want based on a dimension, so it will be a square matrix. You start from 0 until a dimension. You want the matrix of I and I to be equal to 1. As well as you can have an instance initializer. So this is when you've got an object of that class. Okay. So the simple fact is that you don't have the static when declaring your square matrix, as well as when you have your for your instance initializer. You see that here when you want to initialize your matrix, first of all, to exist for your class, you also place the static keyword in front. While for the instance initializer, you don't set it anymore, so the static keyword misses. Okay, so for example, what you can do is to have the default values. Like you can have a Boolean value to be false, you can set a char. Okay, you will have them like bit by bit being 0. You can also have an integer, so you can put the 0L, whether it's long, you have F or float. Okay, you have just 0 to store a byte or a short. For the float, you have this dot 0, 0, dot 0. So you say how many digits you've got after the comma, as well as you have your reference type. So by default, you have null, or if not, you can set it as being equal to a name like this one that you provide. So when you have a local initialization, this is when you set it one by one. So for example, okay, this display. All right, this is with int k, but you can also have a loop. I know that we did set it for the car driver. These are instances of the class, but even before with the point or your array. Yeah, this is the one. Okay. When you have a local variable, it's like this I, which is equal to 0, and you want to go through each and every element of your array, such that here when you want to initialize your array, it's like int a, don't forget that you put the squares, and you should say with what it is equal. Okay, so you have a maximum dimension of 10, and this is the case when you assign a random value, which is between 0 and open interval 200. And you just assign for each and every element of your array, which would be the value. Okay. Then for displaying the element by element, you have the A of I. Okay, and you go from element 0 until the end of your array. Okay. As well as based on the type, you can get a maximum value, you can get a minimum value, based on which you can do the sorting, okay? Or you can find out which would be the minimum and maximum method, element. This is for doing also the sorting according to an auxiliary variable. So this is again a case when you've got a local variable, this auxiliary variable, that you declare inside your for loop, And for it, you simply change the elements such that you have an array sorted in ascending manner. Okay. So you simply change this lower or greater based on how you want it to be sorted, ascending or descending. Then for it, you see that you have the final, such that when you have a final, you have the final interest, which you will set. So first of all, you can update a sum based on an interest. But when you will want to update the interest, being final, you will not be able to do it. So this will result in an error. While here, when you've got the final address add, okay, and you want to create a new address, this will not be allowed. But whether you want to change the address, so this is like a set based on a certain value, this you are allowed. Okay. So for example, for this one where you've got here with employee, you see that you can have the final string name and you can set the name to be Harry Mary. But when I want to have the set name, just when writing the set name, okay, based on them being final, you are not allowed. But if instead of this one, I have the one without final, and I will simply comment it, then you are allowed, okay, and you can change the name of that person, okay. And this is a string, so we would return this dot name. When having the set, you can put it void, and then you don't need to return it anymore, it got stored. So for example, I can have here the employee2 dot set name to be Betty, and when I want to display again the characteristics for her, run it again. Okay, the name got changed. Okay, but with final you can never update it. Okay, it remains like that. Then for it, when you have the final classes, so you cannot simply change it. If you have final fields, you think of them as being constants, like you have pi constant to be 3.14, or you can have some final methods. Okay, like you have the currency and to say which is your currency type per country, or simply to have the values which are fixed. Okay. Then for it, you also have the final method. So again, you cannot override them. So it means that you cannot rewrite their behavior when you have to define a subclass. Okay. All right, so let's see. For an employee, which would be a final field, if you would like to think about it?
Name and ID.
Okay, name ID. Yeah, because the name wouldn't change, or you can have your personal numerical number, okay, which remains the same your whole life. What other fields you would have as being also final, if you think? Which would be other examples? As you are. Okay. Let's Any other examples of final keys? Like sinus, cosinus of some values, they are also fixed. You cannot rewrite their value. Okay. Then you can also have your variable arity method, such that it will be fixed, as well as you can add several parameters. So you have this dot, dot, dot. Okay. So here, for example, you want to display and to say which would be the size of your array. So you see that you can get one string or an array of strings. And this is why you have this dot, dot. Let's have it in this way. So as you can see, it's this one we display. For k, okay, I also want to display which would be the length. So don't forget that for arrays, you have this length, while for a simple string, like you can get name, okay, for this one you have the length in this way with round braces. So if I have a public int get name length, okay, return name. So there is a difference. You have the round braces in case of strings, okay, while for an array here, so being an array, not a string, as above, okay, you need the length without any braces. So array dimension is get with length with no braces, okay, because it is an array. So here you can have 0 or multiple elements. Okay, so if we would like to test it, we can have 0 elements, like this k can be 0. Then my k can be 1, meaning that I have just one argument. So as you can see, it recognizes it that it is of type data. Okay. As well as we can have two elements, which are these ones, or you can set it as being a new string and you provide it. Okay, in this way, it will know that for the third case, I have 2 elements. Okay. Then you have a static import such that you will have to reference several types. Like we can have a static of maths to be the absolute value, and it will be based on the package. So always the order is package import class. Have the peak order package import class. Okay. And we will just have inside the class, you will have a final static in. So this is how you can even define your pi value, for example. And then for that class, you can simply have a static method such that you call it without having the instance of that class. So for example, have a public static void, and then I can have a static method, and I can simply have output from static method. This is the case when I don't need an instance of the class. I just have employee, and then I have this static method, okay, without creating any object of my class employee. So this is the difference between your static and instance. Okay, so it will have the output of your static method. Okay, as well as you can have them just a static import from a certain library. Okay, Then what you can also do is when you want to use a value from a static package. So for example, this is the case when I edit card, okay, such that inside card, we need to go check here, okay. We will have static. For example, we have the type of this card, okay, you set it as a string, as being card, or maybe you've got the value of euro transformed in lei, and you wanted to get it from that certain class which contains the value. And in this case, inside employee, you just call type. So you don't even say from where you get it, you just have the name type, and it will know that it is from card. Okay. So this is automatically provided. If I go over here, it knows that it is from PL, the course 6 card, and it will look at this card member which was initialized, such that when I want to display it, I have the card value which is over here down in the terminal. Okay. Also, I can have a for, such that I can go through each and every element of the matrix and array. So for example, we have the sum equal to 0. We have a number of elements from 1 to 5, and I want to go through each and every element. So instead of writing the for, so here what you would have to declare is a local variable int I equals 0. Then I need this I to be less than what? Than my numbers dot length, and I have an I++. For which inside the sum, I need to do the plus of what? Of numbers of position I. And after that, you need to display it. So what I can do, I can initialize again the sum to 0 and to obtain the same thing. Okay, let's see. So the sum is the same, but for the first one, you declare the local variable as being I from 0 until the total length of your array, and you get element by element which you store inside your nums variable. Then what you can do is to have a for, and having int values inside your array, you have an int element. You will have to parse, and you go through each and every element of your array of numbers. So you have it with the plus equal. Also, you can have a matrix of 3 by 3. And in this matrix of 3 by 3, you will go through the rows, but don't forget that rows contain what? These are the rows. So rows are in fact arrays. So this is why you place these braces over here, and you say that I want to get my array of numbers. So as you can see, even when you declare one simple array, you have it in this way. Okay. So even here I can have a new int of 6, for example, and then I will want my numbers to be equal to this one, such that it will also be with new. So you introduce a local variable, or what you can do is to iterate through it. Okay, and you set the value, numbers of I to be equal to some value that you scan. And you provide as a new int of your values. Okay, new int of 6 as being this one. So you have several ways of doing it, or you have it as a new int, or you simply have the values for it. You can add element by scanning it. Okay, with the scanner, you have the scanf, you read from the keyboard, and then you add element by element according to the value which you want to store. Okay, Based on it, you have the rows which are an array, and you will have to parse through all the elements of your array such that you will have the element. You go through everything that you have inside it, inside rows, and sum will simply be plus equal to this element that you've got here. Then we will have the sum, so this is the one which is displayed. Okay, so you have a different manner of doing it. You can have the first option, okay, you have the first way, as well as you have the alternative way. So, second way. All right. Let's see. Then you have the scope rules such that they can be static or non-static. You've seen it that this is based on your methods as well as based on your variables, which you can call according to the class. And also inside this scope of the variable, you declare your each and every resource such that you have them in nested blocks. So as you can see here, you have several blocks. You have 4 blocks. And inside block 1, you have the void main. So here, if you would like to refine and to say that your string args are equal to something, you cannot do it because args already exist defined. Then you can have a digit, which can be z. The second block will be your for loop, okay, starting from an index 0 until the index 10, less than 10, and you will have to increment it step by step, such that you switch based on the digit which you've got. So whether it's a, you just have an int a, or you can have the default, but if you have it again an int a, it already exists at the level of the block. Okay. And whether it is true, so this is another block which you've got, so it exists separately. And if true, it will simply exit it no matter what. And in this way, you see that you redefine I. So being in another context than before, you can initialize it. So here it existed inside the block 3, inside the switch. Here you have another block with I. Okay, as well as you see here that you've got the digit. And now digit is already declared inside block 1, such that you are not allowed to use it anymore, as well as you've got the index. And index already exists at the level of block 2. So even inside the if true, you have access to the value of index. Then this curly brace means that you close the for loop. And at the end, if you want to declare again the int index being outside block 2, you can define it. Okay. Then for the garbage collection, this is when you have your objects that are allocated. And you allocate them one by one. So it is like here, you've got each and every variable, as well as in the case of employee, you just create them. And then for the garbage collector, this all runs in the background such that you can reach each and every variable. So for even this one, the E, if I would like to do a cout of E2, okay, not having the toString, it will simply display the address where you can find it. Wait to run it again from here. Okay, so this is how you see it. You see that in the background for each and every resource, you have the address, and this means that you need to add the toString method. Okay, so you have the string, and you have this toString. Okay, based on which you will have to return, and you can concatenate. And let's say it's this dot name. Okay. So if I run it again, let's see. As you can see, it will be Mary. So you can put them one by one and to have this kind of format, and to say here that I have a name, and then I can concatenate it with name as well as I can put it in this way. You can also, so let's see it until now. Okay, so we have name. Then to see it one by one, we can also add salary as being this dot salary. Also, yeah, I can have the ID, and I can start with this ID to have it firstly, because it is simply, this is how you identify it. So this is like your social security number, your CNP, and how you have them one by one. Okay, so let's see it. So as you have it, you have ID, you have name, you have salary, and you have them all separated one by one. So this is what will be returned if you have the toString added. Then it will be eligible because you have access to it, you can call it, you can also have the manual cleanup. So this is when you've got the system command. Okay, I know that I need to play with it. Okay, it was in the for loop. Okay, so even here you can have the free memory at runtime. All right, or you can have the system, as you can see, and then you have several methods that you can call. Okay, this is for the garbage collector. To say it, you can also have the run finalization such that it will simply run it for those who are eligible for the object, as well as you can get the free memory, total memory. Let's see.
What does the garbage collector do?
This is when you have objects which are no longer used. So you did create an employee. Okay, it runs inside the program. Okay, let's say at the server level, and then you don't use it anymore, such that it will simply be sent to your garbage collector, and then it will simply disappear. So this resource, if I don't have the toString, okay, whoops. If I run it again, yeah, based on this.
Can you recover the data stored in garbage collector somehow?
It will simply be ended. So when you don't have the program running anymore, it simply cleans up the garbage collector. And you can also, so it exists just based on when the program runs. So you see here that you have this reference, okay, for now. But if I run the program again and again, you have a different resource allocated for it. So it's a dynamical memory. Okay, so it will simply assign it to it. So this is just it is like a pointer. A pointer exists just when you allocate your memory and when you have this whole program living. Because you use your random access memory, it's not your RAM memory, such that it gets persisted on some memory. So if you have some backup, like you have files, when you store it and you have a persistent memory, then yes, you can simply recover. But in this way, you don't have it stored somewhere. Okay, so this is dynamically allocated. It exists, it is a pointer, and then it is simply wasted. I mean, you just lose it when you don't have any more electricity, or if I want to delete it, then you won't have any more the reference to it. Okay. So when not using a reference, you simply waste it. So this is the scope of it. If you have many variables which you use just for some period of time, and after that you don't use it anymore, then this one will be automatically called because you don't need to have them stored anymore to occupy your space. Clear? Okay, so for now you will have a small break and then I will continue with the next part. So let me stop.